In this video, we are going to be graphing logarithmic functions, so let's get into it. First of all, we need to graph the parent function of y equals log 2 of x. So let's get started on that. Let's first understand what a logarithm is. A logarithm is just the inverse of an exponential function. So the logarithmic function is just the x and the y values of each point swapped. If you want a better understanding of what a logarithm is, you can check out my other videos. So let's get this graph out, x and y, and let's just start plugging in points. Oh, and before that, let's understand about the asymptote. The asymptote is also just going to be inversed off of the exponential function. Okay, now let's plug in our values. So, our first value should be 0. If we plug in log base 2 of 0, we get 1. If we plug in log base 2 of x, so if we plug in 2, we get 1. Okay, now let's plug in let's plug in 4. If we plug in 4, we get 2. Okay, so and now let's plug in 1/2. So we'd get -1. Oh, these values should be swapped. That's what I was concerned about. If we plugged in 1, we'd get 0. Sorry. Yeah. And obviously, if we do, let's say, 1/4, these will just keep on going halved until they're very close to the asymptote. And I've already drawn this out beforehand. So yeah, as you can see, that is what the logarithmic function should look like. Now we can start using transformations. First, for log base 2 of x, let's understand that this is x in the parentheses. Since it's -2, all of the values should be shifted down by 2. So we can just take the parent function. Let's erase all of this. We can take the parent function, duplicate it, and then move it down by 2 units. And then for here, since the x is in the parentheses, we do the opposite of this. So we'll do the opposite of that sign. That means we've shifted back 2 units. So duplicate, and now it would be here. So that's where our logarithmic function would be. So let's do a little more. Let's do log of the cube log, right? So obviously this is going to be 1. If we plug in 3, we'd get 1. And then if we plugged in 1/3, we'd get -1. And then if we plugged in 1/6, we'd get -2. Same thing for 1/12. So I'm just going to draw. Now we have to connect all the points. Parabolis is going to be hard. Yeah, I feel like it's just better to draw this in. And that is our logarithmic function. Obviously, we have an asymptote that runs straight down. And since we have log base 2 of x, this becomes negative. So all of the points, they basically flip over to the other side. So the positive become negative. So what that means is duplicate. Right, we have this here. And now we flip it. But then we do a mirror horizontally. And if we cut this out, so this is if it was negative x, right? And now back here, for our last question, it makes us deal with this. Log base, we can't use this since, well, let's just plug in points then. I'm ready to get my calculator out. So x and y, and our equation is so let's plug in 3. If we plug in 3, hang on. Just need to put it in again since I did it wrong. So if we plug in 3, 3 minus 2 is 1. So log base 3 of 1 is 0. And 0 minus 4 is -4. So our first point would be 3 or no. Yeah, it'd be 3, negative 4. On to the next one. If we plug in 5, we'd get negative 3. If we plugged in 11, we'd get negative 2. And if we plugged in 12, we get negative 1.9, but we don't have to write that. And now it's crucial for us to find the asymptote. Since this was the first point that appeared, our asymptote would be laid down like this. And now we connect it like this. And that is our logarithmic value. And that is how you graph logarithmic equations. Thank you for watching.